Hey everyone, it's Justin again. We've talked about volume before, but today we're throwing a twist into the mix. Take a look at these two figures, a prism and a pyramid. These two particular figures actually have a lot in common. In fact, they have the same base area and the same height. So here's the big question. How do you think their volumes compare? If I filled both of them up with water, do you think they'd hold the same amount? And if not, how would the amounts they hold compare to each other? Let's find out. Check out this video my friend Kate made for us. The pyramid is filled with water. What do you think will happen when we pour it into the prism? Will one pyramid fill the whole prism? Maybe half? Well, it definitely didn't fill the entire prism, but was that half or? Wait, a second pyramid full of water still isn't enough to fill the prism? Do you think a third one will do it? Ah, there it is. Now the prism is finally full. So how many pyramids did it take? 3. It took the volume of 3 pyramids to match the volume of 1 prism. This means a pyramid has 1/3 the volume of a prism with the same base and height. So if a pyramid with the same base area and height as a prism has 1/3 of its volume, then that means we can use the same formula we used for the volume of prisms on pyramids, just with one small change. For prisms, we used the formula volume equals the area of the base, or big B, times the height of the prism, or big H. Since a pyramid holds 1/3 of the volume of a prism with the same big B and same big H, what's the formula for the volume of a pyramid? For pyramids, we just multiply big B and big H by 1/3, giving us volume equals 1/3 times big B times big H. In this formula, big B is still the area of the base and big H is the height of the pyramid. Think you're ready for some examples? Let's calculate the volume of this square pyramid. We'll need to have big B and big H in order to calculate its volume. We'll start with big B, the area of the base. What shape is the base of this pyramid? Yeah, it's a square. That means for this pyramid, big B will be the area of this square. What is the area of the square? The base and height of this square, or little b and little h, are both 5 meters. Multiplying those gives us 25 square meters. We can substitute that in for big B and move on to big H, the height of the pyramid. The height of the pyramid is the distance from the base to the opposite vertex. It forms a right angle with the pyramid's base, meaning it will go straight out of the base rather than being tilted. Knowing this, which of these dimensions do you think is the height of the pyramid? Since it comes straight out of the base and is not tilted, our height falls somewhere within the center of the base, not along the slanted faces. Therefore, the height of this pyramid is 6 meters. This 6.5 meters is the slant height. Although the slant height is useful in calculating the area of this triangle, it isn't going to help us calculate the volume. So let's get that out of the way. Now that we know the pyramid's height, go ahead and substitute it into the equation. All right, substitution's complete. Now we just need to do some calculations. Go ahead and work through these calculations on your own and get the solution. Pause the video now. What order did you choose to multiply these numbers in? Remembering that the commutative property allows us to multiply the numbers in any order, how do you think that can help make the calculations easier? Well, 1/3 of 25, or 25 divided by 3, is going to give me a decimal that I'd have to round. It's typically easiest and will keep our answers accurate if we avoid rounding until the end. So I'm going to use the commutative property to multiply 1/3 times 6 first. That'll help me get rid of the fraction and still have whole numbers to work with. We now have 2 times 25, which is 50. Since the units for the base were square meters and the units for the height were meters, multiplying those together gives us cubic meters and a final answer of 50 cubic meters. Here's another problem to practice our volume calculating skills. This time we have a rectangular pyramid. Remember our goal here. We need to know the area of the base and the height of the pyramid, so we can substitute them into this formula. What's the area of the base? 7 inches times 8 inches gives us 56 square inches. And which of these distances is the height of the pyramid? The height of the pyramid is the distance between the base and the opposite vertex and forms a right angle with the base, which for this pyramid is 5 inches. If it helps us to more easily keep track of the height, we can sketch it off to the side of the pyramid or even cross out these other dimensions and pretend like they aren't there. These are just ideas, so be sure to do what works best for you. All right, back to our formula. Let's substitute the 5 inches in for the height. Now go ahead and multiply these numbers together, and don't forget about the commutative property, which allows you to multiply them in any order that can help us avoid rounding until the final calculation. So we know that multiplying by 1/3 is the same as dividing by 3. 56 doesn't divide very nicely by 3, and neither does 5. If I took 1/3 of 56 or 1/3 of 5, I'd have a decimal that I'd have to round in order to continue working with. It's best to save any rounding until the end. So I'll save multiplying by 1/3 until my final calculation. That way any rounding can be done at the very end. Instead, I'll start with multiplying 56 by 5, and then multiply that answer by 1/3, or divide by 3. We end up with a decimal that continues forever, so let's go ahead and round it to the hundredths place. What is this decimal rounded to the hundredths place? Since the number in the thousandths place is less than 5, we can keep the number in the hundredths place as is, giving us 93.33 cubic inches. The other type of base we'll encounter is a triangle, like this triangular pyramid. Go ahead and use the pyramid volume formula to calculate its volume. Pause the video here so you have time to think this through. The area of this triangular base can be calculated using the formula area equals 1/2 base times height, with little b representing the base of this triangle and little h representing the height of this triangle. Which order did you multiply the numbers in? I'll stick to the order shown, since 1/2 times 6 is just 3, and then that can be multiplied by 5.2 to give us 15.6 square centimeters. Let's substitute that into our volume formula and move on to the pyramid's height. What's the distance between this pyramid's base and its opposite vertex? Yeah, the height of the pyramid is 7 centimeters. If you got stuck up to this point and need a moment to calculate 1/3 times 15.6 times 7, pause the video so you can do that. Also, remember to think about an order that might be best for multiplying these numbers. I decided to multiply 15.6 by 1/3 first, or divide it by 3, giving me 5.2. Then I multiplied 5.2 by 7, which is 36.4. Although this is the order I chose to multiply, you might have chosen a different order, like multiplying 15.6 times 7 first. Just remember that it's best if the order you choose doesn't require any rounding until the final calculation. Anyways, our final answer for the volume of this pyramid is 36.4 cubic centimeters. All right, nice work today calculating the volume of pyramids. You know, that water video we watched together was really helping me remember that the volume of a pyramid is 1/3 of the volume of a prism. Getting to reuse the same formula and just include 1/3 in it is pretty nice. And we even got some practice sorting out extra measurements that we didn't need to calculate the volume. Great job! Don't forget to follow the agenda on this lesson's cover page to get the most out of this lesson. I'll see you next time.